Hello everyone, my name is Simon Telecarpi and my project covers the impact and information analysis of a car's front impact bar. So modern automobiles are often compared by older people to those older vehicles from the 50s, the 60s and the 70s. And one of the main points of comparisons are the big, heavy and strong metal bumper that those old cars used to have. Especially because modern bumpers are made of layers of different structures and materials that help absorb and then dissipate the force of impact. Mainly because the outside area is usually made of plastic and is it can bend if when you push on it. So a lot of people have the idea that it's not as safe as those old metal bumpers. However, the innermost layer of protection can be seen as a reminiscent of those old metal bumpers. However, it also assists with the energy dissipation. Here we can see what a front impact bar is. You can see some examples of their designs, and on the left picture you can see one after what probably was some sort of collision to a light post, I would assume, based on how the bar is bent. But on the other two pictures you can see one mounted onto the front of the car where it sits, and at the bottom you can see one just clear example of what a basic one looks like. So car manufacturers clearly have performed the tests and analysis on the materials and the design for those impact bars. However, not a lot of information is available online. I wasn't able to find anything regarding the materials or the specific sizes and measurements for them, either from the manufacturers themselves or from research papers. So I can see this project being a good avenue to better understand the importance of this component, since not much information is available. Main objective of this project is to understand and analyze how a car's front impact bar deforms in a way to absorb the energy of a frontal collision, better protecting the passengers of the vehicle, and also visualizing the different behaviors of the different materials commonly used in this application. Here we can see the geometry that I used. I based this geometry on the impact bar from I believe 16 to 18 model year Chevy Impala. It is as close as I was able to get from the real model without having proper measurements, but design-wise, it is exactly the same. However, when it comes to the analysis, I had to simplify the model, mainly the supports, as you can see on this meshing image, which I used to do the analysis, a mesh of size 20 millimeters. And here, after the analysis, you can see the deformation plots. First one is a true scale deformation under a load of 100,000 newtons. Then you can see a deformation with a 2 times deformation enhancement, and then a 5 times deformation enhancement. One thing that I need to better understand and see exactly what's going on with this is that whenever I ran this simulation, the bar, you can see, as you can see on the first image, the true scale deformation, the bar didn't bend at all, especially under this such a heavy load. On my first try, I feel like about a month ago, when I used a more simplified model, it bent over a load of 10,000 newtons, I believe. So I need to better understand why this is happening and what's going on with that. Here you can see the stress analysis from Workbench. As you can see, the maximum stress value was about 93.485 megapascals, which is significantly lower than the yield strain that I used for this bar, which was around 250 megapascals. So the bar didn't fail; it wasn't even close to failing. One thing that was interesting though was the location of the maximum stress. As you can see on the bottom image, it was right on the corner where the mount would connect to the bar. And I thought it was interesting because one could assume that the maximum stress would be where all the force is being applied, which is the front of the bar. But it was very interesting seeing that it was actually at that 90-degree angle, pretty much a 90-degree angle bend. So most of all these bars are made either from steel or aluminum. But as I said earlier, I haven't been able to find, still haven't not been able to find a specific material. Therefore, on my next simulations, I'm gonna try using, instead of structural steel, which have the information right there, the specifications, I might try to use stainless steel, because I believe, based on some of the pictures that I found and stuff, it looks like some of them might be made out of that material. And also aluminum. That'll be interesting to see how those materials compare. And that's definitely my next step on this project. So that I have for now. Thank you very much.